All right, so the thing you're probably thinking about is, wait a second, Chief. I've graphed things like this and they look smooth. I I can graph things like this and it looks smooth. In fact, I'll take a picture because it lasts longer. And you may well wonder, well, we should probably put this on a new page, shouldn't we? Can't I find slopes all the way around? So let's do that. Let's find slopes. Because this is a calculus class, and in calculus class, we find slopes. So if I'm interested in finding a derivative, a slope of a tangent line, dy dx, the way we do this is the same way we did this in parametric coordinates, except that we let theta be the parameter. We take the derivative of y with respect to theta over the derivative of x with respect to theta. We let theta be the parameter for our curve. The thing to note here is that y is r times the sine of theta, and x is r times the cosine of theta, and that's from our last lesson together. So in this particular case, y is r times the sine of theta, and x is r times the cosine of theta. So when we go to find dy dx, dy d theta is the derivative of this with respect to theta. This is a product rule problem. The product rule is so much fun. It's the derivative of the first times the second, plus the first times the derivative of the second, over dx d theta. Dx d theta is the derivative of this with respect to theta. Well, that's a product rule problem. 1 prime 2 plus 2 prime 1. So now the question is, where do I want the slope of the tangent line? Well, let's pretend that I want the slope of the tangent line right here at theta equals pi over 2. Well, if I want the derivative at theta equals pi over 2, then I'm thankful that cosine pi over 2 is 0, cosine pi over 2 is 0, sine of pi over 2 is 1, sine of pi over 2 is 1, sine at, right? Negative 2/3. Now I could pick any other theta all around the mulberry bush, sub it in here, and be done. What is the big thing for you to take away? You have to know that these are true from our last lesson, and you have to know how to find dy dx using those definitions. Product rule, product rule. You have to know how to do that. Okay? Okay. By the way, this graph, graphs of this sort, are named after a part of the body. These are called cardioids, named after a part of the body. There are also, well, let's do one. Let's do -1 plus sine theta. Let's do that. -1 plus sine theta. That graph right there. And again, we'll take a picture. World's slowest picture taker ever. Should have gone to next slide first, but that's okay because you at home are forgiving. This graph. This graph is called that is also a cardioid. Oh my, that's not very helpful. That's better. Here, let's snag a photo of that bugger and superimpose it right on top of the other one there. Ah, no. Yeah, that guy. This guy is called a limison. It's a limison. It's from an old French word meaning snail, oddly enough. So this is the r, -1 plus 2 sine theta. Looks very much like a cardioid, except it's got a little loop-de-loop in the middle. So if I'm looking for dy dx, if I'm looking for dy dx, then I'm looking for dy d theta over dx d theta, where y is r sine theta and x is r cosine theta. So dy d theta, that's product rule. That's 1 prime 2 plus 2 prime 1. Dx d theta, 1 prime 2 plus 2 prime 1. So now if I'm interested in finding the slope of the tangent line here, here, I have to know a couple of things. I have to know what theta value that corresponds to. So how do I know what theta value that corresponds to? Well, that's a distance from the origin of 1 at an angle of what appears to be 0, except that it isn't, because if theta is 0, then r is -1. So this is actually the point corresponding to theta equals 0. So we figure out that this is the point where theta corresponds to pi, because if this were pi, sine of pi is 0, 2 times 0 is 0, -1 is -1. So you start at -1 and then rotate around pi, and boom, there you are. So if I want to know the slope at this point, then I take pi and in it goes. Luckily, sine of pi is 0, sine of pi is 0. And so we've got this thing here, that's 0, so -1 times the cosine of pi over 2 cosine of pi cosine of pi. So the slope of the tangent line at 1, 0 rectangular point is 1/2. Again, what's the big takeaway? The big takeaway is recognizing how to do this. And I'm going to give you an opportunity to practice that. For r equals 3 cosine of 2 theta, find dy dx when theta is, I don't know, pi over 3. That's something to consider. It'd be nice to take a look at what the graph looks like. This is what's called a Rose curve, for reasons that may be obvious when you graph it. And I have to give you time to do that because this is product rule all over the place. So I'll do that, and I will see you in class.